Hi everyone! Today we'll be talking about the introduction to UDP as part of our discussion today. UDP stands for User Datagram Protocol. It is a connectionless protocol in comparison to a connection-oriented protocol, which has something to do with TCP, and that is something that we will discuss later on. So a connectionless protocol is something that sends packets between applications, allowing applications to build their own protocols as needed. So UDP provides a way for applications to send encapsulated IP datagrams without having the need to establish a connection. So a little bit about UDP. It transmits segments of an 8-byte header followed by the payload. So this header that I have here on the bottom right segment of this slide, I will just kind of go over it really quickly. So we have the source port and the destination port, and then we have a UDP length and the UDP checksum. And then all in all, it is 32 bits all around. And so the two ports that I just mentioned, the source port and the destination port, they are there to identify the endpoints within the source and destination machines. So a way that you can kind of think about this is that ports are mailboxes that applications can rent to receive packets. And they're important because without the ports, the transport layer would be unsure what to do with each incoming packet. So this way we know that these two ports, the source port and the destination port, are very important. And without them, the transport layer would not know what to do, and it would just not work. It would be unsure what to do with each incoming packet. Moving on, we also have the source port, the UDP length field, and the checksum. So for the source port, they are primarily needed when a reply must be sent back to the source. The process that sends the reply can specify which process on the sending machine is to get it by copying the source port field from the incoming segment into the destination port field of the outgoing segment. To continue, the UDP length field includes the 8-byte header and the data, and the minimum length is 8 bytes to cover the header, whereas the maximum is 65,515 bytes. Lastly, the checksum is optional but provided for extra reliability. It checksums the header, the data, and a conceptual IP pseudo-header. And when this is being performed, the checksum field is set to 0, and the data field is also set with an additional 0 byte for padding purposes. So the image to the right is an image captured from Wireshark, and if you've taken 3146 or networking class, you might be familiar with this. It kind of provides the user with information about all things UDP. So it'll show you, the source port, the destination port, the length, the checksum, and everything would be included on the same screen if you are familiar with Wireshark. And so now we're going to be talking about what UDP does not do. So it does not do flow control, congestion control, or retransmission with a bad segment. This is up to the user processes and not UDP. Instead, it will provide an interface to the IP protocol with the added feature of demultiplexing multiple processes using both ports, and this is optional, end-to-end error detection. So that being the case, UDP is helpful in client-server situations. So if we take this for example, a client sends a short request to the server and expects a short reply back, this situation can be done. If either the request or the reply is lost, the client can just time out and retry. So this is kind of a reason, an example of why UDP is helpful in a client-server situation. Lastly, I just have a question for you all. It is a true or false question that I kind of covered in the very first slide. The question is, true or false, a connectionless protocol is known as UDP and a connection-oriented protocol is known as TCP. The answer to this question is true because a connectionless protocol is UDP and a connection-oriented protocol is known as TCP. Thank you.